Generally, inventorying in warehouses is done manually, and it takes higher number of man-hours. Also, it has less accuracy due to human errors, and there are risks involved in reaching higher elevations. In our project, we have tried to address these problems by providing an accurate solution for inventory using an autonomous drone. First, we tried to follow Aruka markers. As the next step, we tried to follow Aruka markers with correct in the heading. Here the drone corrects its heading according to the direction of the Aruka marker. After combining all the results, we were able to scan the QR codes while following Aruka markers with heading correction and maintaining a constant height. Here the drone is navigating without using the GPS. Next, I'll show you how the scanned QR code data is sent to the server using Telnet. You can see the initial view of the web application. Here, the right-hand side terminal is the Telnet server, which is in the laptop, and the left-hand side terminal is the Telnet client, which is in the drone. Here, we have accessed the drone through a SSH connection. Then we start the Telnet server first and the client next. You can see how the login process happens and how scan data is sent from client to the server. Here we can retrieve data from server using the web application. Finally, we tested the autonomous marker navigation of the drone in an indoor environment. We have developed a customized drone with 27 by 27 centimeters in size and 1.4 kilograms in weight. Drone is capable of navigating autonomously using a marker-based approach. While navigating, it reads QR codes on packages by analyzing camera feed using image processing technique. It sends obtained data to warehouse management system through Telnet in real time. Through our project, we were able to deliver a drone-based solution to the inventory management problem.